Lesson 10. As usual, you're looking for the tasks for U3L10. You can find it under assignments or on the weekly calendar. Today's date is December 11th. We're going to start off with our usual chat room discussion. The question for today is, how would you spend $1 million? So if you had $1 million, how would you spend it? And now I know it's obviously a lot of people, you would just want to invest it and try to make it last longer. Let's be ridiculous. Like, what's some like that you would go for? Like, all right, forget it. I'm not going to save this. Like, I'm going to spend this. Or if you really do feel like, no, I would really invest this, you need to tell me what you would invest it in specifically. Like if you're going to go for stock or something, I want to know what stock you would actually go for. So think about that for 20 seconds. On the docket, we are going to be focusing on the drinking bird for the next two lessons, today and tomorrow. And so I've got a quick survey just to see who has this and who doesn't. Don't panic if you don't. It's okay. You don't have to lie. I just want to see who does and who doesn't. If you don't have it, it's okay. There'll be alternative activities, alternative videos, all the stuff you can still do. I see 5 people have already done the survey, but just really quick, it's literally one question. So just indicate on that survey whether you have it or not. I'm just going to time for like 2 minutes. If you need to go like dig through your stuff to make sure you have it, or if you don't, if you're not sure, you can take 2 minutes to do that. Otherwise, we'll come back together quick. Again, it's just one question. This is step number 2 on tasks to complete. Drinking bird survey. Make sure you're filling out Sci2C. You guys are Sci2C. And then the reading quiz, I'm seeing about 10 attempts on, so there's still a couple people who need to try this. This is just more math practice, right? It was the reading from the chemistry textbook along with a couple questions, some really helpful examples, I think, that you can kind of frame your work off of. Please check out those Tyler DeWitt YouTube videos too. If you're so confused by the math, he does a great job of breaking it down step by step. Any questions on that or anything you found challenging? Okay, we're going to wrap up our gas law stuff today. There's one more law we need to cover, which is called the combined gas law. So just like in our previous class, I have a short little ed puzzle for you to complete. It's just over 9 minutes long, I think, 8 minutes. Yeah, just over 8 minutes long with 2 questions. One is a math question, so you'll need a calculator. You can use your phone or whatever else you need to. I'm going to time for 15 minutes to work through it. I'm hoping it won't take that long, but once it looks like most of us are done, we'll come back together. So take 15 minutes to work on the combined gas law ed puzzle. The slides in the video are also available right below if you want to look at those separately, but otherwise focus on that puzzle or the alternative Google form. Go for it. Let me know if you need help. Was just an example problem. This one was a little unusual because they're actually giving you an unknown pressure at the start. So you just had to understand that P1 is your unknown, right? So we know our first volume, 28 liters. We know our first temperature, 45 degrees Celsius, convert that to Kelvin. But then we don't know the initial pressure. Then you're given final volume, final temperature, final pressure. Again, had to make sure that you converted temperature into Kelvin. So you got to add 273 to 45 and just set 35 to do the math of that. And then it just comes down to being able to do your multiplication efficiently and cross multiplying and dividing. But the correct answer was 2.51. You can see the work on that slide as well. So I encourage you to check out the slides if you struggled with this. And again, just getting more practice is the key. So hopefully the homework was helpful. Check out those videos by Tyler DeWitt. But I would say equally, if not more so important, is the concepts behind this, right? And the relationships between these variables. So this question was, you have a gas and you decrease its pressure. So remember, pressure and volume have inverse relationships, right? So pressure goes down, volume is going to go up. While also increasing its temperature. What's going to happen to the volume? Remember, temperature and volume have a directly proportional relationship. So if you're increasing temperature, you're going to increase the volume. And so in both cases, decreasing pressure and increasing temperature, both of those would contribute to an increase in volume. So that was the correct answer, was volume would increase. So just try to keep those main concepts in mind, right? And the math is just kind of representing those. Any other questions or comments on that? All of this has been to build up to talking about how this toy, the drinking bird, works. So I'm just going to show you a video and then let you go to do a little activity on your own. But here, let's just watch the drinking bird at work. No one's seen this before. Old silly desktop toy. So it's called the drinking bird because it does this tipping motion where it'll tip into water, has a little bill that it drinks with. But what I want you to pay attention to is the red liquid on the inside. Look at that red fluid and what it's doing. Right. Not the most exciting thing in the world, but hopefully you notice that as the drinking bird is standing and kind of slowly doing this wobbling back and forth, but not dipping completely as it's standing, what was that red liquid doing?
Rising.
Very good. It's climbing up through the tube. And then as the drinking bird tipped over, what happened to the red fluid? As it tipped over and came right back up again, what did the red fluid do?
It went back down into the.
Very good. Back down into the bottom bulb. That's the driving mechanism behind this. It seems silly and kind of simple. It's actually very complicated physics that's going on behind this, and is a possible hint of what's called a perpetual motion machine, which is technically impossible, but this is one thing that gets kind of close to it. And so I'm going to let you go to do a little activity where you're going to try to explore this a little bit using your drinking bird at home, or if you don't have it, then I've got a little demonstration video. So just to show you where you need to go, we're on the last step on the tasks to complete, step number 5. Click on the link right there, investigating the drinking bird. It will take you to a Canvas quiz. If you have your drinking bird toy, you're going to need a few other things. You're going to need a water source, a tissue or towel, a phone for a little bit of filming. There's a super short flip grid I want you to do. You'll need a glass or a mug that's roughly as tall as the legs or the base of your drinking bird toy. And you'll need a bowl with some ice or some very, very cold water in it for the activities that we're going to do. If you don't have your drinking bird toy, then you can just watch this demonstration video. It's about 6.5 minutes long, and it's me going through this quiz. So just follow the instructions on the quiz questions and then answer the questions. They should be pretty straightforward. The second to last question is a very short Flipgrid post. All I want you to do is film your drinking bird actually drinking, just like the video that we saw earlier. But I would also like you to just briefly voice over what the liquid is doing. So just say as you're filming your drinking bird, look, the liquid's rising, and then the drinking bird tips over, say, oh, the liquid fell back down. That's all I need to hear. Keep it short and simple and submit that. And then the last question is your chance to take your best guess at how you think this works. Why does the liquid climb up the tube? Again, you don't have to look anything up. I'm not looking for right or wrong answers here. I just want to see what your ideas are. You're going to do a very detailed reading for homework on exactly how these toys work. So let's see. I'm going to time for 20 minutes to work through this. And when it looks like most people are done, we'll come back together. Let me know if you need help.